Welcome to the Chorus One podcast. In this podcast, we explore the emerging open financial system facilitated by scalable, interoperable blockchain networks. Tune in every Monday to dive deep into cutting-edge projects and protocols with Chorus One team members and guests.
Hi, and welcome to the Chorus One podcast. I'm Brandon, and today I'm here with Alwyn Culwick from the Blocknet. Hello, Alwyn. Welcome to the show.
Hi, Brandon. Great to be here.
Yeah, so just a little bit of background on Chorus One. Chorus One runs infrastructure for public blockchain networks. So we run validators on various different Cosmos zones, including the Cosmos Hub. We're also running testnets on Solana, on Kava, and some other projects, including Kusama, the Polkadot testnet. So over time, we just add more networks. We're big believers in the future where there's a multi-blockchain world. And as we've been digging around, looking at various different proof-of-stake networks and various different interoperability technologies, at various times we've come across the Blocknet. That's really interesting. We should have a look at that, do a deep dive. So I invited Alwyn on the show to kind of go through the technology. So hopefully we can do a kind of compare and contrast course. I've been looking into Cosmos's inter-blockchain communications protocol and their vision for what this interoperability world looks like. The Blocknet vision is somewhat different. So I think we want to just kind of dive into some of the details. So Alwyn, do you want to just kick off and kind of give us some background of the project and just kind of set the scene really for what the Blocknet is?
Yes, absolutely. The Blocknet started in October 2014, and it arose out of a series of conversations about what it might look like to decentralize the internet. At the time, the conversations were very broad, but we identified two things that we thought we could deal with very well and that would make an enormous difference. One is that the internet currently runs on the API ecosystem, so-called, which is a simple thing where just thousands and thousands of companies are exposing their services over APIs. And that means if you're developing an app or a website, you don't have to code most of your app or website. You can make very powerful applications without really needing to do all that much work. And that's what powers Web 2.0. It's what enables such a rich ecosystem of bits and pieces. So, simple things like you don't have to code a payment gateway. You just plug into one of the ones that you want to use. You don't have to code a two-factor authenticator. You don't have to code kind of anything really except your application logic and maybe your own database. And then the front end. Now, we thought it would be kind of nice to do something like that with blockchains, because even in 2014, there were about 1,000 blockchains out there, all doing interesting things, but they didn't speak to each other. And that leads to the second big thing we wanted to knock out, which is just to allow blockchain to interoperate, but without sacrificing their unique properties. Most centrally, the fact that they're decentralized. I just realized that statement. That sounded a little weird. Most importantly, the fact that they're not decentralized. But in addition, enabling pretty much any type of service, any type of contract to be consumable from a different chain without having to have that other chain locally, but nonetheless still being able to go to operate in a trustless manner, which of course is critical unless you want to just sacrifice the entire thing and stop bothering with blockchains and just trust a traditional API. So that's the big vision, at least from my perspective. It is the API ecosystem decentralized, but equally it's making all blockchains be able to interoperate and to therefore expose their services over decentralized APIs, which then gives developers an equivalently rich ecosystem to exploit and allows them to build things very easily. Instead of trying to deal with a very complex underlying blockchain code, they can just orchestrate and focus on UX.
Okay, great. So I guess part of that vision then would include something like being able to have token interoperability, right? So if I'm building an app and it needs to rely on 10 different networks and they each have different tokens with, different ways of paying for gas, different ways of, accessing the services, I guess then this kind of like token interoperability becomes key, right? So is that part of the vision behind having the DEX then to be able to have a way to quickly move between tokens?
Yeah, that's exactly right. Early on, we realized that the ability to frictionlessly monetize a service is possibly the major business advantage to a decentralized API ecosystem. The other one perhaps being that because it's so trust minimized, you could do business with people without taking on any of the traditional risks that you take on with the trusted world. But yeah, absolutely. We got to monetize these services. Otherwise, who is going to be incentivized to support them and run them? And so what we did after our first, I think, very sort of early stage interchain proof of concept was develop this thing called XBridge. It's now our backend for Blockdex, which is a really nice consumer app that traders can use without really needing to understand anything about what's going on underneath. But XBridge is this trading engine. Now, to go back a few steps, and we thought long and hard about how to do this. And the approach that we took is that we thought one way to go about this type of thing is through the use of colored coins, so to speak, and approach that's been used many times and is still extremely popular. And it started with now called the Omni layer that used to be called Mastercoin, and then there was Counterparty, which basically did the same thing, but there's just all kinds of things. Waves, the project today, is basically just colored coins as far as I can tell. And then ERC20 token standard came along and everything went wild. Now, because it's so simple to build and because it's been implemented all over the place, it would have been a kind of an appealing approach to take one way or another to make a token kind of exist on a different blockchain. And that would mean you could build your DEX, so to speak, on a suitable blockchain, and any tokens you want to trade on that, virtualized on this blockchain, and off you go. And that's still appealing, actually, but I think for different purposes. The thing is that what we realize is that if we're developing an interchain protocol, that type of approach basically centralizes the interchain. It means that instead of us building a true interoperability, as a true series of interactions between blockchains that are protocol driven, we would end up basically going, oh, well, you can use some cool thing that we built, but to do that, then you basically have to kind of plug into our important chain, which does all the fancy stuff. And all the other chains don't really do much. And so there'll probably be one event where you park your coin somewhere and the users receive a colored coin in return. And then all the fancy stuff that you want to do, in this case with token swaps, would happen on a specific blockchain. Now, that's not really interchain in my view. It doesn't give us what we want. We don't want a system where everything kind of decentralized around one chain. And it also led to this other problem, which is that in some cases, not necessarily decentralized exchange, but in some cases, what you end up having to do is store the state of any number of events on any number of other blockchains on your central chain, and that just ends up duplicating the data and then requiring you to have finality on your chain about other chains. So you're doubling up the finality, which is doubling up the work. And in essence, what you end up with is a sort of a duplicate of every other chain on one middle chain, which is ridiculous. It's absolutely not a way to scale anything. And it doesn't give you an interchain. As I said, it just gives you a bloated central chain. So these are, in a sense, philosophical considerations, but I'm sure you noticed they touch on the performance of the chains, they touch on real concerns about centralization. And so what we ended up doing is going for true interchain trading. So the trading engine decentralizes not only the settlement of coins between different chains, but it also decentralizes the other three core aspects of an exchange, which is the capital storage. Coins are only in the wallets that you use already on your computer. It decentralizes the compiling of the order book. So traders compile their own order books independently of anyone else and gossip the orders to each other. And then it decentralizes the matching engine. Specifically, the makers of a trade, or the people who are adding liquidity, are the ones who choose their counterparty. So the matching engine is decentralized to everybody who adds liquidity to the exchange. And yeah, with that approach, we're very satisfied that we can monetize, or we can allow developers to monetize their interchain services. And of course, what we did as well is we built Blockdex on top of that, which just exploits the trading engine for crypto trading.
Okay, great. I think that's really interesting because it answered one of my points of confusion, right? One of the things I heard you say, like in various different presentations you gave, is that a kind of hub and spoke model, like the Cosmos model, would lead to kind of some kind of centralization or some kind of winner takes all model. So your argument there is that the reason it does that is because the hub ends up being this kind of decentralized custodian of assets and therefore maybe has kind of wields too much power in the ecosystem. Whereas your view is nobody should be this decentralized custodian. Assets should just be stored on their native chains. And the DEX allows you to kind of have that flow across chains.
Yes, I think that the chains themselves should be the ones that are orchestrated together, and the orchestration between the chains is the interchain service. I guess for me, this is a point that is true by definition. It's kind of a trivial point, just because it isn't interchain if you're only interacting with one blockchain. Now, that doesn't follow automatically that everything should be interchain. Quite the contrary, every single interchain service has things going on one blockchain, which are made available to another blockchain. So there's always quite a lot of stuff going on that's just on that one blockchain. I guess what I'm getting to is I've already mentioned some points about finality and about doubling up finality, which is just redundant and unnecessary. But the other thing is we don't want to create a turf war. We don't want a repeat of Betamax and VHS. We want a proper interchain standard that is completely unopinionated with regard to which blockchains are used. Because if we have that, we have the potential to create the tremendous ecosystem benefits of the internet. Instead of just this turf war where there are kind of 6 or 7 or 8 or however many so-called interoperability projects that are basically competing for users and are required to compete because of the nature of their protocols. We want something that transcends that type of model. We want something that gives everyone the ecosystem benefits that I think we all want.
But what about the argument? I mean, this architecture puts the Blocknet very central. So if I'm an app developer, I speak to the Blocknet and then the Blocknet talks to other networks. Is that not the case?
Like that? Well, yes, but no, because the interchain tech that we've built doesn't run on a blockchain. You put it this way, there are some core components. There is a peer-to-peer interchain network. So it's an overlay network, which means that if you're a node on the interchain network, you're also a node, at the very least a light node, an SPV node on one or more blockchain networks. And so in a sense, yes, maybe this network overlay is the Blocknet or something, but it's not the same as having a blockchain, which is sovereign. Every blockchain is its kind of own state in the sense that it has complete, like the network has sovereignty over what counts as true. Now, that's just not what's happening in a mere peer-to-peer network because there's no blockchain plugged in there, right? It's just people gossiping to each other. So I don't think there's any kind of control issues going on with that type of system.
Okay.
Now, if you throw in a blockchain and you require every user to then depend on reaching a finality about contract states on that chain, then I think you do have a problem. It's not just that you're now depending on whatever that chain says about it, an event that almost certainly going to be an event on a different chain. This is especially the case with Polkadot. Again, I said these kind of network effects that probably going to result in a tragedy of the commons where everyone's basically competing to persuade users to go down their proprietary pipe and extract a little bit of value because everything's going down that pipe. We don't want that. I think it's very important that we avoid that as an ecosystem.
Yeah, I can certainly see the case like with Cosmos. If Cosmos is there as the decentralized custodian, it kind of adds somewhat of a fork resistance, right? Because it's very hard to unwind who owns what assets, right? If people feel, if a subset of the Cosmos community feel that the governance of the chain isn't working out and they want to fork it, it's very hard to kind of figure out how do you fork this if it controls a lot of assets, right? So I can see how this model will be more advantageous. Like the more decentralized the assets are, like it seems like the pathways to forking around issues are actually stronger, right? Is that assessment correct?
It's not the way I would say it. To me, the ability to either avoid or use forks to your advantage is a blockchain level design problem. And it's super interesting. I mean, it's a great problem, but it's just not an interchain problem, properly speaking. We're just agnostic about this stuff. If a given service wants to actually build a protocol around forking, where you can, this is a concept that's becoming more popular because of the Moloch DAO concept. We're fine with that. It's really not our thing. And if people using that type of design principle want to make something available on the interchain, we've literally got nothing to say about it. We'll just provide tools that will help them to enable their service to be consumed by people on different chains or on no chain. So I guess what's going on in my understanding of things is there's a lot of confusion between blockchain and interchain. I don't think people have understood very clearly the distinction between the interchain and the edges of the interchain. For me, every blockchain service that's on the interchain exists on the edges of the interchain. And so with things like what Cosmos has built and is building, those are blockchain services. And it's not to say they don't also have a particular interchain component to them, but I think what's required is to just distinguish between what's interchain and what's blockchain. And then to me, the situation becomes a lot clearer. My takeaway is that Cosmos are building amazing technology. I'm absolutely going to use it if I get an opportunity to build something. But I'm not going to be suffering under the illusion that what I'm using is interchain. I'm going to probably use their blockchain services. I might use the interchain aspect of it as well. I'm not really sure. It depends on the use case. But one way or another, I think what's going to be happening is that the hard work and the really difficult problems that Cosmos are solving are making their blockchain useful to people on other blockchains. And that's great. I just think that this distinction is critical. It's really like a fundamental, not just a terminological and conceptual distinction, but it's one that actually allows us to see the shape of the entire space and ways it might develop.
Try and have a stab at kind of explaining the difference here, right? For me, as I understand it, right, when I look at Cosmos, right, it's a classic hub and spoke model. So it's more like your kind of airline model where you have a hub like London Heathrow, and, you know, there's different connections come into the hub and then they go out. So like most of the traffic that's passing over an interchain is going to go through this hub, right? And then over time you end up with more hubs, you know, so you get like Dubai or Kuala Lumpur or some other hubs that start to form that connect all the chains together, right? Whereas when I think of your model, to me, it looks more like the London Underground, where architecturally it doesn't look so clean, but I think there's some powerful advantages to it, right? So when I think of, say, you know, the Circle Line or Hammersmith and City Line, right, they overlap quite a lot. So the nodes on those train lines have a lot of overlap, and that might be, you know, a Bitcoin and a Litecoin and an Ethereum. The chains that have a high level of overlap. So if I'm running a node on Ethereum, I'm highly likely to run a node on Solana or some other chain, right? Whereas you've got other chains that maybe look like the Central Line, where they only have 2 or 3 touch points with other chains.
Yeah.
Is that the way to think about it, or does that help?
I think that's a great analogy. Thank you. I think that does help. I also think, though, that it's an aspect of the analogy that doesn't touch the all-important thing about blockchain technology, which is that it's decentralized. As I'm sure everybody knows, the thing that we are decentralizing is control. So let's say you're using Bitcoin. As a user of a wallet, maybe not a miner, you act in a self-sovereign manner. There's no third party that needs to check who you are or give you permission to spend coins. You just do it. And that's the beauty of this thing. Now, one of the more interesting aspects and maybe confusing aspects of decentralization in the context of blockchain tech is that reaching consensus, mining, for example, in the case of Bitcoin, it makes a compromise to self-sovereignty. Now, it does that so that you don't have to trust that whatever messages you're receiving from your peers are in fact honest. It solves the business general's problem, and that's an enormous achievement. But, you know, I think it's really interesting that because of this small sacrifice of self-sovereignty, a lot of the time people think that if it's decentralized, then it's about reaching consensus through, you know, something like mining and proof of stake. And they kind of lose the sense that, you know, what we're actually doing is we're decentralizing control. And that's why almost no one can distinguish between the distributed and decentralized. That's kind of hilarious. Now, the way the point I've been making affects the image about the London Underground versus the hub and spoke model of the world's airports is that in blockchain technology, the whole thing just becomes meaningless if you're not decentralizing control. Imagine someone built a blockchain where you had to kind of ask some central player's permission in order to do something. That would be anathema. Everyone would just be like, well, this is ridiculous. You could just build a server and then gain all the performance advantages and not really introduce any more trust than you've already introduced. Now, that's not the same scenario as Cosmos's hub and spoke model, because each hub is itself a decentralized system. But you've already noted the potential risk that some people might get quite worried about, which is that there might be sort of all sorts of complicated forking concerns when there's an issue. My issue with something like Polkadot is I can't really see when there might be an edge case that leads one of the Polkadot chains to reach finality, but finality which differs from one of the other blockchains they're supposed to be kind of telling you the finality of. And then what you get there, you're going to have absolute carnage. And meanwhile, I don't even think that was necessary in the first place, because you could have just relied on the original chain's finality, because that's what blockchains do. They reach finality about state. You don't need to double that up ever. So it's one of these kind of interesting things where you You're taking a sovereign system, a blockchain network that on its own reaches finality about something, and then creating a second system that's kind of reaching finality about the other finality, and then you've got a huge potential conflict of control. And it's very confusing as a user what you're supposed to do there. I'm not sure at all what I would do if I were caught in the middle between these two systems. You see what I'm saying? I think there's something going on in these designs that really troubles me when it comes to decentralization. It just doesn't seem to be solving a problem. It seems to be introducing more problems.
Yeah. So let's dive into that, because I think, to me, that's the crux of the issue here, is trying to figure out, like, what is the actual difference, right? So let me just quickly, for the listeners, just talk through how Cosmos IBC works, and then maybe we can contrast that with the Blocknet, right? So in Cosmos, say you have Cosmos Hub and you have another chain. So let's say it's the Kava chain. So they set up a root of trust between them, right? They establish a connection, and they do that by kind of understanding, right, who are the validator nodes that are active on the hub and who are the validators that are active on the Kava zone. So they exchange that information, they exchange the signatures are the keys for the various validators that are running on the node. And then when the message is passed from the hub to Kava, it's very easy. Then you just have a light client on each end, right? And the light client is just kind of looking at the messages, confirming that the transaction was actually written to the hub. And then the light client verifies that the transaction is there, and it checks there's enough signatures on the block header. So I can see how that works. Now, in your model, if I start with the developer, right? So I'm a developer, I'm building an app, and I send a transaction, and I send a transaction to the Bitcoin network. And say then I need to have another action that I'm taking on another chain, and that chain then needs to confirm that actually a payment was made on the Bitcoin network. So can you walk through how that works? Like, how do you actually verify that that has taken place? How does the second chain confirm that the payment was made on Bitcoin, and therefore, that they can proceed with whatever transaction they need to do?
It's really, really simple. The user does so, or the user's software does so. So let's say it's an atomic swap. I'm going to sell you a Bitcoin, and you're going to sell me some Litecoin. Right? We're swapping Bitcoin for Litecoin. Now, I will be running a Bitcoin wallet and a Litecoin wallet. Or if I don't want to have two blockchains and maybe a phone or something, then I'll just need an SPV multi-wallet, which then will have connected to several nodes on each blockchain and can independently self-sovereignly construct an SPV proof by querying many nodes on each blockchain and receiving responses and checking if the responses all concur about the state of the chain. So what happens is, I'm selling you Bitcoin, right? I will broadcast a bail-in transaction, which is spendable by you and only by you, and it needs to be spent within a certain period of time. And let's say that you, in our little swap, while we were setting up and swapping keys and whatnot, you generated a random number, which is a secret. Now, the transaction I broadcast is only spendable upon revealing of that secret, right? Basically, the transaction contains a hash of the secrets, and I don't have the secret, you've got the secret. Now, if you spend my transaction, that requires you to reveal the secret. But now the secret's in the public, and so that means I can spend your transaction because I've got the secret. Now, none of this involves Litecoin and Bitcoin being able to, different nodes on each of these networks, being able to kind of independently check and then release funds. It's just me and you who are gaining this knowledge and who care about this knowledge. And that makes sense because it's just me and you who have an interest in the trade. No one else really cares. And so we don't want to give other people work to do in order to facilitate this thing, at least not any sort of special work over and above mining. And that's all that happens. The two of us, the users, are the ones that can broadcast transactions on each network, and we do so in a particular sequence. And in so doing, we swap coins atomically with no counterparty risk. And it didn't require anything else than this self-sovereign action to get the two chains to interoperate.
Okay, cool. But is there a use case where a chain has to verify a transaction? So if I'm developing an app, like in this world of a mashup, right, where I've got this kind of microservices-like approach, my app is trying to use 5 different chains. Is there a scenario where a chain has to verify, like a payment was made on one chain and then the other chain has to verify that payment was made? Is that a different use case, or is that just the same as the one you've described?
I think I'm seeing things like that happening. I'll put it this way, I was kind of enthralled by the announcement of TBTC, which is a project by Keep.
Yes.
It looks to me like the first properly trustless Bitcoin on Ethereum type of thing. It's really, really cool. What's going on there is they got this really complicated process, and I'm yet convinced it's the most efficient, especially the most capital efficient way to do it. But it's amazing either way, and I'll use it no matter what they do. Basically involves a whole bunch of people co-signing something on both chains, and I guess that to me roughly corresponds to the whole delegated proof of stake concept that Cosmos is using. So I think it's a decent enough analogy. Mm-hmm. Not perfect, of course, because all the other miners on both chains don't know the first thing about TBTC and they don't care. Mm-hmm. But there's something similar because it's multi-party. In this case, they gain from this type of process because no one person needs to be trusted to act honestly, and by having this sort of large multi-computation, they get to more or less put Bitcoin on Ethereum, and that's amazing for decentralized finance. And because you don't need to trust one or a small number of people, it probably will incentivize people to use the system. Now, that's great. I think that's fantastic. There might turn out to be more use cases like this. And if that's the case, then great. Bring it on. I think it'll be a very interesting world, and I cannot wait for people to build this sort of thing. And I guess to me, this is where Cosmos to me becomes really interesting. I think Cosmos is doing something highly analogous, but using it's a bigger approach. They're using their own chain, some sort of special chains that kind of do this well. Although, as far as I'm aware, there's not a lot going on at the moment. There's not a lot in production apart from some kind of cutted coins in the hub, right?
Yeah, for sure. I mean, IBC is not live yet. I mean, I think Cosmos is just...
But IBC, I'm very excited about it. It's beautiful. I think it's an amazing piece of work. At least the specification is amazing. I can't wait till it's in production. On the other hand, I've never seen a situation in which this particular approach is necessary. This doesn't mean I've gone and looked at the business world in any real level of detail for this use case. So there are many specific problems that will be solved best by this approach. But on the other hand, in the case of TBTC, I sketched out an alternative approach in this really, really great conversation on Twitter that happened, and I chatted to Mats that same week about the whole thing. He was at Blockchain Week in Berlin at the same time as I was. I think you can do the same thing, but with almost perfect capital efficiency without involving multi-party computation. It's the multi-party computation which then needs people to sort of lay down a whole bunch of Ethereum collateral and then suddenly consuming very large amounts of Ethereum to lock the BTC in place. And that's the typical capital inefficiency we're seeing at the current stage of DeFi. Now, if instead of that, I had some Bitcoins, right, I could broadcast a transaction that enables me to spend the Bitcoins back to myself in 9 months, for example. Really, really simple, check, lock time, verify, and it's done. Now, what I can then do is I can go and prove on the Ethereum network that I've now done this. No one can spend that Bitcoin and only do so in 9 months. I can then use that proof to create TBTC, right? Now, before I go too far ahead, there needs to be a system where people on Ethereum can check the contract state on Bitcoin. So they would see that I broadcast that check lock time verify contract, and they could prove to themselves that it actually happened. Now, this is exactly what XRouter, the blockchain router, does. It just allows you to query nodes in different chains and construct SPV proofs. So that'll work out of the box to facilitate this computation. From there, if I create TBTC on Ethereum, which has a kind of an expiration date well in advance of the 9 months, so maybe call it 8 months or something. So there's a full month of finality troubles that it's likely possible that Bitcoin can get into for these things to kind of be finalized in advance of. Now, let's say you have a crowd of people doing this, creating TBTC. You then have a contract that basically able to sort of pull these things and release what I call FBTC, fungible BTC, which doesn't have an expiration date, but is always in proportion to the total number of TBTC coins that are currently in existence. This is kind of simple, right? It's not simple in a sense because it's a couple of layers up on top of Ethereum, and these contracts are complex, but it's a lot simpler than creating these multi-party computation things, which require a lot of collateral, and there's still kind of crazy black swan events in which People would no longer be incentivized to play nice with that type of system. Yeah, I think with this other system, the beauty of it is you can compute entirely every single moment at which the Bitcoins backing TBTC are going to become spendable again. You have a complete picture of the entire system the whole time. There's never a point in which you're going to be surprised. It's kind of perfect. You can always know when TBTC is going to need to be destroyed. I don't know how you get better than that in a sense. And it doesn't require any multi-party computation. It's purely self-sovereign the whole way. So you gain capital efficiency through a self-sovereign approach, as opposed to losing capital efficiency through a multi-party computation approach.
That sounds really, really cool. I think I followed most of it. Like there's one or two bits that I wasn't too sure about. But I guess the first question I'd ask then, you start with non-fungible BTC, right? Because each BTC has a different expiry date. And you're saying there's some transformation then to make it fungible. Is that subject to kind of assumptions? Because I guess the amount of BTC in circulation is going to be fluctuating all the time, right? And potentially when there's a panic of some sort, then, you could see a lot of withdrawals and that could sharply be reduced. Well, not sharply, because I guess there's a delay on most of the BTC, but potentially, you could see that being reduced. So what happens in that scenario where you start to see a fall off in the supply of BTC? How does that unwind then in the rest of the ecosystem?
Well, because it's my BTC, I have gone and created the TBTC, and by then essentially kind of lending someone FBTC, I'm taking on the risk of the TBTC disappearing. So I'm imagining a scenario where by taking on the risk of dealing with this TBTC FBTC ratio, maybe I haven't sketched it out clearly enough. At point X, check what time verify is going to mature on Bitcoin, and that will mean that my TBTC will disappear. And that will then mean that there is insufficient TBTC to back the FBTC. So I think to me, what I'm looking at is something really simple, like by taking on the risk of dealing with the TBTC FBTC ratio, I get to charge some interest. So anyone who wants to use FBTC pays a little transaction fee or maybe interest over time, something like that. A small amount of risk, I make a small amount of money, and in doing so, we have a tiny little hits in capital efficiency, but we gain nice trustless Bitcoin on Ethereum.
That's essentially the banking model, right? Where somebody's getting paid for taking on that risk and they're trying to manage the assets over time and potentially they can hedge in various different markets to make sure that they're protected.
I don't really think about it as the banking model because the issue is you've got to trust the banks, whereas this entire system is computable and like really in its entirety. You can learn everything about the system. It's all on blockchains. Whereas, with banking, you've got to trust regulators and you've got to trust that the banks aren't being too corrupt to really cause a problem. And, I guess I don't think of something like maybe Compound's not the best example or Uniswap because there's some trusted aspects of those contracts. But if they were completely trustless contracts, I wouldn't think of those types of systems as like banking, even though you can like loan and borrow crypto using Compound at interest rates. But it's definitely like banking in the sense that there are people providing capital for the fee.
Yeah, I guess, I didn't mean literally like a centralized. I mean, I guess, banking probably started off fairly distributed anyway, It's just that idea of taking on the risk that, you have to manage the supply of an asset over time. And you're trading, like today, you're trading in money markets, just trying to make sure that you have enough supply to meet your needs at any point in time. So I guess it reminds me of that a little bit. But no, I think it's a really cool idea. I'd certainly love to see something like that. Just talk about the DEX, right? To me, it seems like the biggest challenge here is just liquidity on the DEX, right? So I think it's great. There's this vision of all these hundreds of chains that can interact and they all have their own token and, native tokens and gas fees, etc. But presumably the liquidity issue is fairly troublesome, right? It's hard to get enough liquidity in any DEX, right, these days, right?
I guess so, but I think looking at the growth of BlockDEX, it's not fundamentally different from the growth of any other exchange, centralized or otherwise. I think we've seen it start slowly, and like anything, these are any exchange. There's no liquidity because there are no traders, and there are no traders because there's no liquidity. But as liquidity increases, then more traders will feel it's worthwhile for their use case to use the exchange, and then it ramps up, and the next thing you know, it really just goes vertical, and you have an enormous number of users coming in. And I expect something similar is happening with BlockDEX. Exchanges almost always have a pretty slow start. And they ramp up, I think in our case, there is also a significant usability improvement coming. There are a few, I guess. But the biggest one is the release of there's somebody building a multi-wallet, an SPV multi-wallet. And that will mean you could trade all kinds of coins, and pretty much almost any coin, without downloading a single blockchain locally. And that's amazing, because you can just fire up Blockdex, and the wallet is there, and that can store all your coins. You don't need to worry about like 100 and whatever gigabytes of hard drive space for Bitcoin. You just start trading. Although the beauty of it for me is that if you want to use your wallet and you want the best security, because you don't resort to SPV, you just have a full node, you can. And the thing will work automatically and will configure itself, and you'll be trading without any real hassle at all with your own wallets if you want to. But yeah, I think like for your average user, maybe somebody wants to trade on mobile, we'll come up with essentially an SPV multi-wallet instance or version of Blockdex that runs on mobile and allows you to trade without downloading chains. I mean, those sorts of things really do improve the usability. But yeah, fundamentally, I think we're basically on the same type of curve as any exchange. You just start slowly and you keep on with it, and the next thing you know, you've actually got a massive amount of volume.
Yeah, so there's various different models we've seen for liquidity incentives, right? Now, some of these haven't launched yet, so nobody really knows if they're going to work, right? But things like Vega Protocol seem to have this kind of liquidity rewards for market making, basically. Gnosis, StutchX have it. I guess in Uniswap, there's some rewards for providing reserves. Do you see something like that being necessary to kind of incentivize market makers?
Actually, yes, we're onto that. So first off, you don't pay a transaction fee if you're adding liquidity. So that's one of these kind of incentive schemes where if you're a taker, you pay, but if you're a maker, you trade for free, which is great. That works. But at the same time, we're also launching this kind of market making thing. So we, Dan, my co-founder, coded this bot that runs in Blockdex. Not to say that anyone else can't come and do the same thing, but you can run market making bots or scalping bots or anything that really does earn you the spread or help you exploit being on the maker side of the market. So I guess we're working on that. We're paying quite a lot of attention to that at the moment as a team. And that will definitely help the volume and the depth. But yeah, I think like anything else, these problems, they don't solve the thing entirely. You do need actual organic market growth. I guess maybe that's not really true. I'm sure there's at least one centralized exchange that has done insane levels of wash trading for long enough without getting caught that people started using their tech and off they went. But we're not about to do that, so we're just going to do it the slower, more honest way.
Well, look, that was great. It was really good to talk to you. Is there any last thing you'd like to say, like what's up next, what's happening? Is there any kind of message you want to give to our listeners?
Yeah, we're approaching production release of XRouter. It's been in beta for most of the year, I think. Something like March or whatever that we released XRouter in beta. XRouter is the first blockchain router. I think it's extremely exciting because it allows you, through a simple API, to kind of orchestrate contracts on any chain. I'm not exaggerating when I mean any chain. It really does work with all the blockchains. It basically plugs into our peer-to-peer Interchain network. So you can query up to, I think there are about 500 nodes on the network now. So you can query a whole bunch of nodes about the state of any contract on any chain, receive the responses, and then prove to yourself what the state is. And from there, you can just do that with anything interesting on any blockchain and create interchain dapps where you're not really dealing with contracts, you're not dealing with blockchain code, you're just pretty much orchestrating. I think it's incredible. I'm super, super proud of it. And the documentation is up now already. It's on api.blocknet.co. I think this is a big one. I think when it hits production, I'm really excited to see how many people take an interest in it. And if there's anything that your listeners should check out, I'd say it's that.
Okay, that's great. Well, thanks a million for your time today. Really great to talk to you. Fascinating discussion. And we'll have to keep digging into this a bit more, and we suggest all our listeners do as well. I think you're one of those projects
that should run a service node, huh?
I certainly do. Yeah, I'll definitely take it back to the guys. And I think you're kind of one of the hidden gems, I guess, in some regard of the whole interchain space. So we definitely want to make sure that you get more. We can help you build awareness because, I think it's an amazing set of technologies you've built, and we have to keep in touch.
Thank you for listening to the Chorus One podcast. Visit chorus.one for more information about our work. Don't forget to subscribe to the podcast to stay tuned on new episodes airing every Monday.